problems, yeah, it's better to have a picture. Do you still have my email address? Don't send it to my phone. Send it to my email.
Yeah.
davidcowan1949@gmail.com.
Yes. Let me see.
Are you using an iPhone?
Yep.
Make sure you attach it as a large image.
Okay.
Gives you a choice, small or large. Small doesn't work at all, really, but large allows us to see it with pretty good resolution. Tell me when it's been sent, when it says on your end, sent.
All right. Yeah, I just got it.
There it is. Okay. Let's download that. I love math problems that are full of words.
Yeah.
I'm being facetious, actually. I hate math problems that are nothing but full of words.
Those are the hardest ones.
Which one are we looking at?
The one I was having problems with was number 8.
Okay. Number 8. Which one is that? I'm not seeing the. Oh, hold on. Sorry.
It's that one. It's right there. Yeah.
Yeah. Okay.
So I pretty much got like sections of it done, which is kind of weird, but I think the thing I was having problems with was like finding the area of that top part of that hexagon.
Okay.
On that.
Here's the bottom part of the hexagon.
Yeah. Yeah.
And a prism means that the top part looks exactly like this. A prism has to have two equal and opposite and parallel sides.
Mm-hmm.
Now, in other words, the other side of the prism looks something like that. And the aquarium looks like that. You with me?
Yeah, I gotcha.
I think, and it doesn't really matter whether it's on its side or whether it's on one of the bases. In other words, if it's a vertical aquarium, it's not going to matter. It's going to hold the same amount of water.
Right.
Okay, so the way we're going to get the volume of that aquarium is to find the area of the hexagon.
Yeah, times the height.
By the thickness between the two hexagons, which we'll call H. All right, now let's see the hexagon. Oh, is this picture over here supposed to? Oh, I see. Now I'm seeing the picture. I didn't see the picture before.
Oh, yeah. That's the picture we're using.
So H is 24 inches. Hold on, let me. And the hexagon is 8 inches on each side.
Mm-hmm.
Okay. Hold on. Okay, do you remember the formula for the area of a regular prism?
Yeah, for this one, it's 1/2 NAS.
Okay. So we know N, and we know There's 8 sides, and each side is 8 inches. What we have to solve for is this apostrophe.
No, there are 6 sides, right?
Oh, excuse me, sorry.
Yeah.
I thought it was strange that they used the number 8 twice just to confuse you. I hate it when they do that. So,
yeah.
better this way. Okay, so we have to solve for that apothem. And in order to solve for that, we have to know what that angle is. Because we know this is 4. So if I can figure out what theta is, then I can solve for A.
So I would just take like 360 divided by 6, right?
Correct.
Yeah.
What's that make theta?
That's 60 the degrees, and then if you cut that in half, that's 30. So that top one is 30.
In other words, that's 60 degrees there.
Yeah.
1/6 of the hexagon is 60, which makes that 30, which means the triangle we have to solve is a 30-60 triangle.
Yep.
And you don't need trig for that. In other words, if I draw that triangle over here like this, there's the 4, there's the 30. What's that side? If that side is, oh, hold it. We don't know that that side is 8.
No, yeah.
If this is a standard, in other words, what's A? Do you know?
Yeah, because it's a special right triangle, so is that 4√3?
Yeah. Yeah, exactly. Yeah. 4√3. And now that's all we need. In other words, that's 4√3. And now we can solve for the area of the hexagon. Now, I guess we need to get a number because there's other stuff involved here, the weight of water and all of that stuff.
Sure.
So let's see, what do we got? We got 96√3 is the area times 24 is the volume. Do you have a number? Do you have a calculator?
I do, but it's not. I forgot. I kind of lost my charger to it.
Well, hold on. Let me just. I want to leave it in √3. So I'm just going to multiply 24 times 96. That's 2304. So the volume of the aquarium is 2304√3. I think I did that right. 2 times 48 is 96 times √3 and then times the thickness. Yeah. Okay.
Yeah.
Now let's look at the rest of this. The aquarium without water weighs 48 pounds. How much will it weigh when it's full? Well, water weighs 63 pounds per cubic foot.
Yeah.
Oh, how am I going to figure out the weight?
So do we need? I think we need to multiply it by the √3 to like kind of get a more exact. Because I know that's the exact, like that's more exact, but.
Let's find out. Maybe, maybe not. First of all, if this is in cubic inches, correct?
Yeah.
That's what volume is in.
Yeah.
And water weighs 63 pounds per cubic foot. So 63 pounds per cubic foot. Well, I need a conversion for cubic feet to cubic inches. How many cubic feet are there in a cubic inch? Or I should say, how many cubic feet per cubic inch?
Yeah.
Well, there's 12 by 12 by 12. So if 12 times 144, 1728. So this number is, there is 1 cubic foot per 1728 cubic inches. Now, let's see if all of our units cancel. That cancels with that. That cancels with that. That's going to give me the weight of the water that fills the aquarium.
Mm-hmm.
And I add to that the 48 pounds that the aquarium need. How much will it weigh when it's filled? Okay, hold on. So let me get a number for that. That is our answer. 2304 times 63 divided by 1728, 84 root 3. So 84 root 3 pounds is what the water weighs.
What does that multiply together?
Well, 84 times square root of 3. No, my calculator won't do that. Hold on. 84 times 1.71. Is that what you're wanting?
Yeah. What's the like the decimal for it, or whatever it comes out to?
143.64. 143.64 pounds is what the water in the aquarium weighs. Okay. Since the aquarium weighs 48 pounds, then the total is 191.64 pounds. That's what aquarium and water weighs. And so she needs a desk that'll hold 191 pounds. Now, if small fish need 180 cubic inches of water to swim around in, how many small fish can the aquarium house? Well,
is it 22?
Well, hold on. It's this number. That's how many cubic inches it is. If I divide that by 108, 108 or 180? 180, that's how many fish will swim around in there. So let me get that number. 2304 times 1.71 equals, and then I'm going to divide that by 180, and I'm going to get 21,888 fish. Seems like a lot.
21,000?
I'm wondering.
Sounds like fish abuse.
Well, I think maybe my decimal point might be off. Yeah, it's got to be.
Okay.
No, it's got to be 21.8. Here, let me do it again. I'm on this calculator.
Okay.
Just a basic desktop calculator. So, yeah, that's 3,939 divided by 180. Yeah, 21.8 fish. I guess 22 fish.
Okay. Yeah. Round that up.
And 22 is what they get. Okay. And it will weigh 19 pounds when filled. Where'd this answer come from?
No. It was gonna be. I knew it was in the 190s, like a rough estimate of it. So I was waiting to fill the rest in.
Oh, okay, I get you. And what did we come up with? We came up with 189.
No, I wasn't saying
190 is close enough, probably. Make sure you put the 0 in.
Yeah, it was a rough estimate. So
Notice that 19 can't be right because it's less than 48 even.
No, I know. I was just scribbling down because it was a rough estimate because I knew it was in the 190 area.
Okay. That is a cool aquarium. I think that would be a nifty aquarium to have it sitting on the hexagon as the base.
Yeah.
And go vertical like that. So you don't see very many aquariums like that.
No.
All
Just
right.
can't stop pushing there.
You got any other problems on this page that you're not sure about?
Not really, but probably if the one y would probably be the least strong, would probably be 6.
Okay.
At the very top.
Uh-huh. Let me read it. Okay, so if a block of ice is floating and it causes the water to rise by 4 centimeters, it means that only the volume of the ice that is below the water is what's causing it to rise by 4 centimeters. So,
right. So you can just find the volume of the water that was
yeah, in other words, you've done it right. 4 times 35 times 50. So 2,000 cubic centimeters of volume were displaced. And what's the volume of the block of ice? Well, 2,000 would equal to 1/8 A. No, 7/8 A. Correct?
What'd you say?
Well, let me think about this for a second. What did we just solve for? We solved for the displacement amount. So 2,000 were displaced. That means my block of ice...
Wait, what's 2,000?
That's the amount of water that the 7/8 of the block equals. In other words, here's
So
here's the block of ice floating in water, okay?
Yeah.
This is 7/8 and this is 1/8.
Right. That's what was above and below.
And the 7/8 is equal to 2,000. So I got 7/8 of 7/8 of the volume of the block of ice equals 2,000. And they're asking, what's the volume of the block of ice? So the volume of the block of ice is 8/7 times 2,000. In other words, the entire block of ice doesn't displace water. Only the 7/8 of it that's below the level of the water. So,
I see. Okay, I got it.
According to my picture, you see how that, in other words, 7/8 of the block of ice is below the water. Yeah. It's only this part here that's displacing the water. So that part of the ice is equal to 2,000. So 7/8 of the volume of the block of ice equals 2,000.
Okay.
And then whatever
that makes sense.
Whatever 8/7 times 2,000 is the answer.
Perfect. Okay, that makes more sense then. Yeah. So okay, cool.
Okay.
Got it.
Anything else?
Well, since it says 7/8, does it have to be 7/8?
Meaning, you want an answer for the volume of the block of the ice? As a 7/8 as opposed to what?
As the 8/7.
Well, that's because 7/8 of the, notice the entire block of ice is not 2,000, right?
Yeah.
Got to be bigger than 2,000. It's only 7/8 of the block of ice that's equal to 2,000. So if I solve this algebra problem, in other words, I've got 7/8 of the volume of the block of ice equals 2,000. Therefore, the volume of the block of ice equals 2,000 times 8/7.
Okay.
Here, I'll give you a number on that. 2,000 times 8 divided by 7 equals 2285. So 2285
Yeah, that's what
is the volume of the block of ice. And notice that if you took 7/8 of that number, you're going to get 2,000, which is exactly right, because 7/8 of the volume of the ice is floating below the water, is responsible for the water rising only.
Yeah. Okay.
Now, in number 7, it's a combination of figuring the volume and then figuring the density of gold.
Mm-hmm.
And notice that the density of gold is in grams per cubic centimeter. So if I multiply the density of gold by whatever the volume we come up with, that's going to give me the total grams of gold I'm going to have. So you got the volume of the medallion, is that correct, 160?
Hopefully.
I haven't read the problem yet, so...
yeah, that's what, yeah, when I did the math on it, but...
Let's see, it's 1.6 times 100, so yeah, 160. And you...
Yeah, and then it's gold.
Where's this mass number? Oh, it has mass 3088. Oh, I get it. Okay. So he comes up with the volume of that rock. 3088. Here, let me do something real quick here. So you've got 3,088 grams, and I've got to divide that by 160 cubic centimeters, which will give me grams per cubic centimeter. And if I do that division, I get 3088 divided by 160 equals 19.3.
Yep, that is gold.
That is gold. If I'd have come up with a different density, it might have been lead or fool's gold or whatever.
Right.
The secret on a lot of these problems that use different units, like when you get into volume and density and things like that, just make sure your units cancel. Well, I didn't need to cancel units here. I knew that the density of gold is 19 grams per cubic centimeter, so I'm already in grams per cubic centimeter as long as I divide the grams by the number of cubic centimeters. Because you sometimes
then you're
don't
good,
have to divide or multiply. Well, you do whatever is necessary to make your units come out right.
Yeah.
In this case, that's division.
Right. And then it works out pretty good.
The secret. All right, Ben. I'm going to let you go. You don't have any questions?
What's that?
I said if you don't have any further questions, I'll let you go.
Oh, I'm good, yeah.
You good?
Yeah, I'm good.
Okay. Talk to you next time. Have a good weekend.
Okay, great. Thank you.
Bye-bye.